Good morning, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. And I will quickly share my screen. Okay, so guys, first of all, good morning and welcome for this session. And today we are going to discuss about the fundamentals of Apache Spark and Azure Databricks. So I'll walk you through the module link which we have, which you can follow after the session first, and then we will jump into it. So if you go to the meetup page, you will find that on the meetup page, we have the further learning link over here. And if you click on this link, it will basically take you to the Spark architecture fundamentals on MS Learn. And you will notice that on this MS Learn, there are various sections over there on this learning module. And you can open these sections, and whatever we will discuss today, all those things uh, will be uh, will be also mentioned in these pages in a very well structured way. And you can even go one step back over here. You can see the associated learning path over there, data engineering with Azure Databricks or data science with Azure Databricks. So in whichever field you are more interested in, that field you can go for. Now, if I open, just want to walk you through a couple of these pages here. So if I just open this first one, you will notice that we are talking about the problems of big data, the velocity, the volume problems, and then how to understand the Databricks Spark cluster. So if I just go next, you will notice that there is a very high level overview. We will understand all of this today in the session. However, this is just to, you can say, this link is also there from where you can do the revision once you have understood the concepts. And the Databricks is not a one-to-one map with what we call as a Spark, which is yarn based. It's not. It doesn't. It's not a. You cannot map it one to one. There are differences, so we will understand the differences as well. And we'll create these clusters and so on and so forth today. So you can after the session, you can go and you can have a look at these links for the purpose of you can say self-learning as well at your own pace. Okay, so I'll just get started. Let me just close all these pages. And the very first thing which I want to do is I want to create my own Databricks cluster. I would like to start from some resource creation today because it takes time, and by the time we will discuss the concept, the clusters will be ready. So what I'm doing is I'm going to my resource group, and I should be having a resource group called as Databricks resource group over here. And I was just doing something over there, and I guess if I just zoom in it for you, or let me do one thing. Let me create another RG over here. Let's say another fresh one. And we will create reactor RG. And in this reactor RG, we'll do the deployment. So let's create one RG. And I am just going to go and create one Databricks workspace there. I'll explain what is this, but it takes some time to get created. So we will come to Databricks as well on the way. And We'll understand what we did, but I'll just create it first for you. And today is one of the fundamental sessions on Spark and Databricks. So we are doing things more from the scratch itself. So you can see that I'm coming over here and basically I'm giving I have to name it. So I'm calling it as Databricks workspace over here. And there are two things which we'll be discussing about, the standard and the premium pricing. Now, the premium pricing is generally what we go for in the production workspace. I'll select it for now. I'll explain what is that once it gets created. I'll click on create and the validation is going on right now and done. Okay, so this workspace will be coming up over there and we will wait for that to be there. And in the meantime, let's go to the whiteboard and understand the basics of Spark and how does it works. So the now there are two type of cluster deployment modes which we can talk about. The one is called as the cluster managers can be of two types in production. Generally, we go for the yarn-based cluster manager. That is the standard one, which is all the services in the clouds also use the yarn-based cluster manager. However, I will also give you a few liners on the other one as well, Kubernetes-based cluster manager. Now, when you create any Spark cluster, this is how it might be looking like. So you have the master nodes, and then we have the workers here. So I'll just make some boxes and check this out. So imagine you created this cluster and it is having two workers and one master. That's how we will be configuring the Databricks as well. So that's why we'll keep it the count to be two workers and one master. Now, before even I jump into this, if I just want to give you an overview of the ecosystem of Apache Spark, this is how basically it looks like. Right. So when we talk about big data tools, the big data tools, they require Hadoop distributed file system to be present over there for the purpose of storage of data. So this is HDFS, and this is where we have the big amount of data kept inside the HDFS. Now on top of HDFS, in this diagram, I'm going to put the component which is called as yarn, yet another resource negotiator. And on top of this is where I'm just going to put the you can say the parallel distributed or parallel computing engine. So you must have heard about the word uh, Hadoop before. So that is what we have over here in the screen. That is MapReduce. MapReduce or Hadoop 2.0 is MapReduce. So basically we have the mappers and the reducers where we do these are the two type of operations or two type of jobs which we run the mappers and the reducers in the Hadoop cluster. So we'll understand about this. But if I create this green box, this is what Hadoop looks like. You see this? So it has these three components over there. Now, when Spark was open sourced, it's basically the one which is replacing or which is competing against the MapReduce, and we can put the Spark over here somewhere in the big data ecosystem. So this is the ecosystem of big data. Now, if let me just put it like that. Now, see, the reason we have all of these solutions are think of any job which takes a lot of compute resources. Maybe you can think of maybe something which comes to mind like machine learning, where a lot of compute resources will be utilized during during the execution of the job. Now, if you do not run the job parallelly, it will take more time. And the problem is you also have big amount of data. The data might be very big in size, or it might be coming very fast, and also may grow in size very quickly. So because of all these reasons, you would like to run your jobs in a parallel way. So let's say you created these 6 nodes in the cluster, and this is where you have the big amount of data which is lying in one object storage or in some data lake in the cloud platforms. So you see, or maybe in HDFS itself. So data is coming from here. That's the compute cluster. Now, this is your job. Let's say that's the job. Now, when you write the job will be written in some programming language. So the job might be in, let's say, Java. It might be in Python. It might be in Ruby, C++. So the most logical thing which you can think of is that can't we have a technology which can basically, you can say, map the jobs to various nodes over there, and then the job executes on all of these nodes, let's say over here, and then once the output comes back, it reduces the output back, it aggregates the output back, and we get the output like this. So that technology was MapReduce over here. Now MapReduce is slow. It is way faster than your single nodes and like your laptops and so on and so forth, or any other resource which comes to your mind. However, MapReduce is slow. The one of the reason why MapReduce is very slow is because of the disk operations which happens in a lot of disk operation happens in MapReduce, or the outputs are stored in the or intermediate outputs they go in the disk as such, which makes it very slow. Now, when Spark came into existence, Spark is the one where we do in-memory computation. So one of the reason why Spark is very fast, it's just FYI, it is around, you can say 10 to 100 times faster. That's how we put it, faster than Hadoop jobs. So think of any job in Hadoop which is running in 100 minutes, which now you can run in Spark in 1 minute, like this. So one of the big reason why it is so fast is in-memory computation. Apart from that, we also have concepts like RDD, resilient distributed data sets, and the optimization which Spark does. So all of them together makes your jobs 10 to 100 times faster. Now, the so when you think of this technology, this thing which we have created here, if that is Spark, then when you create the cluster, it might be looking something like that over there. If I take you back to Databricks, and let's see if that Databricks is ready, uh, we will just open the workspace and we'll see if we can quickly maybe create one cluster there. So this is the workspace is ready of Databricks. So if I, in the meantime, I launch it from the portal, I will just take you back to my whiteboard and would just explain what we have done there. Now so we have created one workspace of Databricks. Workspace can be is basically we are representing the workspace like this. Now what this workspace will be doing is anything and everything which we create, any job which we write, uh, any cluster which we create will be inside this workspace. Now this workspace, so for example, now once I go back to the Azure portal, I will create one cluster there. Let's say this small cluster over here, right? So what happens at the back end, all these resources, they will be created in my Azure subscription. So there is one resource group which will come automatically, which is called as a managed resource group. You see this? Another new resource group. We never made that. One more resource group will automatically come up, called as managed resource group. And whatever any clusters which I'm creating will get created over there. So these are the virtual machines which are coming up over here. And any associated resources for that virtual machine might be the NIC cards, might be network, or might be any disk which is required for it. So all the things they come up in the managed RGs, which there is, you cannot go and manage it from there. You don't have any rights. So what you have to do is you have to come back to the workspace and you can manage your resources from the workspace. So I can write my jobs, I can schedule my jobs, I can have multiple clusters over there, and these clusters will be the ones where uh, we'll be executing these jobs, right? So let's say over here, so some jobs like that. So the very first thing which I want to show you, before I do that, I'll just create the cluster. It takes around 3 minutes for the cluster to come up. So I'll just click on it first, and then I'll take you and I'll explain all the things. So I am inside Databricks right now. I have launched the workspace. I'll zoom in for you, and we'll create one cluster here. Now, so let's name it as cluster. And this is the Spark cluster which we are talking about. Now you will notice that there are different type of cluster modes: high concurrency, standard, single node. We'll discuss it out, but we'll make the standard first. It takes around 3 minutes to create, so we'll just click on it first, then we'll come back and we'll discuss it once it's ready. I'll reduce the cluster size. It depends on your requirement. It depends on the quota which you have, or the budget for your project as well. So I'm creating this cluster, and see, it is having uh, okay, it is having some, if you can notice over here, 14 GB RAM and 4 cores over there. So we have the worker types and the driver type. Driver is where this is the one which we have in the diagram as the top one over there. So if we go back, this over here is that one, the master over there. Okay, so we'll make it first and then we can discuss it out. So I'll just quickly click on create cluster. Okay, now in the meantime, it comes up. I'll take you back to the workspace, and we'll see if I can just show you those options again. So if you remember, I just showed you that there is, if you click on the workspace for the first time, there are two options which are there. The third one is a trial. So third one doesn't matter. Uh, you will be using the first or the second one, the standard workspace or the premium workspace. So two type of workspaces are there. Now, in the premium workspace, what happens? There are a couple of interesting things which are there, like role-based access control and credential pass-through. So if I take you back to the whiteboard, I would like to explain what is credential pass-through. That is something which is very useful, and Microsoft also recommends uh, that you should be like if you when you will do this in production, you should be using the credential pass-through option over there. Now uh, the option is basically that if I bring my Active Directory, so this is the Azure Active Directory. So the entire subscription is trusting the Active Directory, and the Databricks is just inside the subscription. So if you look at all these purple users which we are creating over there, right? So these users are basically these are our colleagues. They are part of the organization. So if this Active Directory belongs to contoso.com, then all of these are Contoso employees over there. So what happens? Let's say now out of these employees, we have these two of them over here. Now, what you want that when this cluster, so that's the job which they are running over there. So we have the user one and the user two, and that's the job which they are running individually. Maybe first the user one runs and then user two runs with his or her credential. So what happens? Imagine that this data was available in this location. This can be a database. This can be a data lake, if you know that, or storage accounts, object storage as such in Azure. So this can be any of the location where the data is lying over there. Uh, so just FYI, ADLS is the one which replaces HDFS in Azure Cloud. Like we don't prefer HDFS because of the cost factor of having real HDFS is very expensive. Versus ADLS is extremely, you can say, it's very extremely durable. It's the redundancy is the SLAs are beyond the chart, and it is way uh, easier to work with. So, for example, now you want that when the user number one runs uh, the job. So this is the user number one over here. User number one is having reader rights like this. So you want that when user number one runs the job over there, then reader right should be applicable because user number one is the one who's running the job. So what happened? The credentials or the rights which user number one is having on the other resource on this one is applied during the job execution. This is called as credential pass-through. Now, this is something which is very useful and very interesting as well, because now you do not have to do the user management two times or the rights management two times. And this is user number two over here. I'm changing the color, but that's the same user. So let's say when the user number two is the owner of this or maybe the contributor or is having write access as well. That's how I can put it, is having write access as well over there in the data lake. So when the user number one runs, the job can simply do read but when the user number 2 runs the same job, the uh, the code is running with user number 2's rights, which are there on the resource. This concept is called as credential pass-through, and it's very useful for us. So that option comes in the premium workspace. So that's the one which which is recommended for you to go for. And standard one is not the one which has all these features. So you can maybe for any small company as such, that might be useful over there. Third is just the trial. So you can try the, if you do any lab of Databricks, you can simply try this one. So for 14 days, they give free Databricks units over there, which will make it your cluster runtime will be free of cost. So for 14 days, you can try that out. Okay. Now, once you make the workspace and you launch it, that's how it opens up. That's how it opens up, right? So if I take you back and over here, and if I simply click on the compute again, so the previous cluster is running right now. You can see it's in the running state. That's good for us. It got started. But if I take you back to the create cluster option, you will notice there were 3 types of clusters over here. The third one is single node, high concurrency, and standard. There are 3 options over there. So the one which we created was standard. We can create any 3 of them today. However, the single node is a single node. Like there is the driver and the worker. There is only one node. It's only one machine as such, right? Single node. So it's used for dev and test purpose. Or if you really have very small data set, you can also use it. Now, the high concurrency cluster is called as shared cluster as well. This cluster will be shared among various colleagues. So if we think of contoso.com over there, back again, where there are multiple colleagues who want to run the job and they are sharing the same cluster. So this cluster should be the high concurrency one, which will be able to support concurrent, you can say, runs from various team members and so on and so forth. So that's the high concurrency one. The one which we have created is a simple standard cluster. Now, standard clusters are also called a single user cluster. Let's say if you have 2 data scientists and you want to isolate their work, or the work which is happening in one cluster should be isolated from the client works which is happening from the other cluster. Maybe different clients are there, different projects are there. Then you can go for standard clusters. You can go for the standard clusters over there. And the standard clusters are basically can also run pretty heavy jobs because they have these, it's only dedicated for that one job and so on and so forth. Now we have the options such as if I click on this one, you will notice that we have the options where we can enable the auto scaling. We can also have the termination of the resources after some X amount of time. These are very useful for reducing the cost. Now the cloud, it becomes very you can say cost effective because of the pay as you go model. We can deprovision the resources when we are not using it. So if your job runs in 1 minute, you can deprovision it. You don't have to run for 100 minutes as such. So if these termination things over here will be very useful, you can change these values. You can set to something which is more useful for you. And the cluster basically doesn't deletes, meaning next time when you need it, the configuration is anyways saved. Next time when you run the job, it will get started. Now, if I click on the workspace over here, I'll click on the users. And in this users, I will click on this my user. That's my login name right now. And I'll click on this icon over here. And I can create new notebooks where I can run my various jobs over there. So you can see we have Python, Scala, Spark SQL, and Spark R over here. PySpark, Scala, Spark SQL, and Spark R over there. So, or you can also import the notebook. So today I will be importing one notebook. I can click on this URL and I'm just going to my secondary screen where I have copied the link with me just before the session, which I would like to import from. and I'll do a simple copy paste and I will import this. So we are doing the basics today. So we'll won't be you can say we'll be seeing something which is very interesting, but we'll see if we can understand the basics more as such. So if I take you back to the Spark architecture, so this is what we have created over here, like this, right? Now that's the master node, and this master is having these two workers, which are simply virtual machines, which are running in my Azure portal right now, like this over there. Now, if I and that's where I am. So I would like to run one job over here. Now in Spark, what happens when there is a component in Spark called as a DAG scheduler, uh, DAG scheduler, DAG scheduler. So what it does when you run your jobs, it will break your jobs. So let's say if this is my job, so job is representing my the application which I want to run. This is my app, my code, my app, my job, my application, something like that. My Spark application, my Spark job. So there is a component called as DAG scheduler in Spark. What it does when I will run my job, there are more details over here, which I'm simplifying. However, what happens when any sort of so what the DAG scheduler will do? This DAG scheduler will basically break this job into stages and into task. So DAG scheduler, and then so my job is now broken into stages. So let's say stages are there, and then so that was my job, and then this stage is having various tasks over there. So let's make maybe 5 tasks. So I don't have to write much in the whiteboard. So that's my tasks over there. Now the task inside the same stage, you see this, these will be executing in parallel over there. Now we will be making another box here, and this box is representing your data. So this is what is representing a RDD, resilient distributed data set, and this is basically your data over here. This is representing your file or data, or and so on and so forth, like that. Now this data is basically we are thinking of very big data, big amount of data. So it is having partitions there. See, it's having these partitions. Now there is a one-to-one mapping between the task and the partition. So if you have a lot of partitions, you will have a lot of tasks. One partition will be processed by one task over there, something like this. So one-to-one relationship. So having a lot of partition at times will also backfire, because you will have more partitions, more tasks which are running, more overhead as well. So it's not that always by having more partitions or more tasks, things will work fine. Now there is a couple of things which I would like you to understand over here. There is something which is very confusing for people to understand. So I'll just take you back to the documentation of Databricks once, then I'll tell you what I want you to remember. So this is this is a Databricks documentation for basics of Spark. I'll give you this link in the chat as well, in case you want to look at this link later on, or you want to bookmark this, because you may also need that. And let me see, where did my chat window go? Okay, the chat window found it. Sorry. So, okay, so okay, so there is one statement which we will remember. We'll read together, and this is the one which is confusing, and we are doing it from Databricks from their own documentation, right? So this is the one which you will remember. Let's read it once, and then I'll tell you what I mean by that. Now we are using the term slot here to indicate that threads are available to perform parallel work for Spark, and Spark documentation all often refers to these threads as core, which is a confusing term because the slots available on a particular machine does not necessarily have any relationship to the number of physical CPU core on that machine. So the cores which is written in the Spark documentation doesn't relate to the physical CPU core. Now, why it doesn't relate to it? Why doesn't it one-to-one map with it? because the calculation is like this. For example, if I have one physical CPU core, so let's say this is one physical CPU core, one physical CPU, and this physical CPU is having, let's say, 8 core. Now these 8 core will be having multi-threading over there. So let's say 2 multi-threading like this. So how many slots do I have? So I have basically 16 slots over here in one CPU core. So this CPU, so this slot word is the one which is more, you can say, standard versus uh, you can say core, because core is the one which is little more, which is confusing. Now, so slots is equal to the number of tasks as well, which I can run parallelly, or it is equal to the number of core, which is what we understand in the Spark documentation. So the physical mapping of the CPU to how many tasks you can run is not right. You have to calculate it correctly. So for example, if I have one, and this depends on which how many cores will be there, depends on the manufacturer as well of your uh, of the CPU as well. So go and check it first. So now, for example, I can run, if this is my configuration, I can run 16, I can have 16 slots. I can run 16 tasks over there, or I have 16 cores, one for one task. So how many can I run over here? Like this, 16 at one point in time. So where are these slots, right? Let's understand this. So if I take you back to the cluster, something like this happens. We will submit this. Uh, we'll submit the application if we have not already submitted that. So, and I'll see if I can create a straight line today or not. Okay, like this. So now when you talk about yet another resource negotiator, Yarn, Yarn is having two components. We have the resource manager and the node manager. So this is the resource manager over here, and the node managers will be here in the workers. This is the node manager. Now the resource manager is talking to the node manager. It's a bidirectional communication. They keep on communicating over heartbeats. So these arrows are representing the bidirectional communication over here, and they will keep on talking to each other. Now, when you submit your job over there, let's say step number one, we'll put one there, right? The the second thing is, so what this resource manager will do, this resource manager will find, it's already knows like where the extra, where we have the slots available, where it's already things are going on, and so on and so forth. So what that resource manager will do, this resource manager will find the nearest, not the nearest, the appropriate node manager. Let's say this one, that's the appropriate node manager, and will ask this node manager to launch the uh, to launch one container over here. So step number 3, you see this. This is one container which is coming up here over in this node over here. So we are talking about the Spark architecture right now, the open source Spark architecture, which is based on which is using the Yarn as the cluster manager. The other one is called as, we can also have Kubernetes based Spark. And I think 5 to 6 session back, I discussed, there was one session on which we have already done it, where we did the deployments on Kubernetes using the Spark operators in Kubernetes. So if you're interested in the other one, you can go and check that out. Now, you see this is where we have the container. Now this container is not a Docker container, so don't get confused over there. This container is basically it's an unit of resources. We can put it like that. It is having CPU and it is having, let's say, some X amount of RAM over there. Now what happens? The uh, so what happens in this container is where the application master will come up. You see this app master. Now app master is responsible for the execution of your application or the lifecycle of the application. It's the responsibility of this app master to make sure that my app runs. So for every single app, for example, let's say this is my app, I am running it. Now you executed your app over there, your hyphen app. This is my hyphen app. So for you, your app master will be different. This is the one which is this application master is responsible for execution of my application. For yours, it will be another one will be there. Now inside this application master is where we have the driver over there like this. So driver is the one where most of the logic of Spark executes over here nearly, most of the logic of Spark will execute here. So driver is having one thing called as a context, or today we call it as Spark session. The context is an old term. Now this is the session over there, Spark session. Now what happens? Let's say this application master got created, and then we inside the driver we have the Spark session, and we have many more things over there. The DAG scheduler we were discussing is also there inside the driver. DAG scheduler, we have the backend scheduler, we have the task scheduler over there. So various type of schedulers are available. So now what happens? This driver will go back. Let's say step number 4, it is going back over there to the resource manager, and is saying that resource manager, I'm looking for resources. Give me some resources, right? And so resource manager for us right now is having the resources available. So what this resource manager will do, this resource manager will provide some leash tokens back to it. So let's say step number 5, we have the container leash tokens. So container leash tokens. Now with these tokens, what happens? The driver basically goes to the node managers over here. Imagine this one, and imagine the other one, which is let's take it from here somewhere like this, right? So it doesn't overlap. Now that will be step number 6, I guess, over here. So it is going to the node managers and saying, node manager, I have the container leash tokens with me. Launch the containers. I want to do something. So you see in the step number 7, the containers are coming up in the various workers over here. So we have one container here and maybe one container here. This is where I want you to remember that in Databricks, this what we're discussing right now is the generic Spark architecture. Databricks is not one-to-one mapped with Apache Spark. It is, you can say, most of it. It's basically Apache Spark only. However, they have their own way of working. So what in Databricks, what happens? There is one executor in one worker over there. They have kept it one. So for example, in my diagram, I can make it like this, which is totally fine. I can have these 2 containers here. Let's say 3 containers were launched over there. 1, 2, 3. 2 in this worker, one over there. Now inside this is where and let's make another box here. You see this yellow box? This is what I'm calling as executor. So in Databricks, only one executor will be there. This yellow box which I'm trying to create inside the in one worker. So this 2 will not be possible in Databricks. They have designed it in their own way. Okay, now so this is the executor, but it does what we are discussing over here. So this is the executor. This is the executor. And if you remember what we were discussing from the Databricks documentation a few minutes back about the number of slots, so which depends on how many cores do you have and how many parallel threads which can be run over there. So let's say 16 slots. So these slots are basically inside the executor. So we'll make some boxes here. So this is slot. This is a slot. Let's say more slots. And let's bring more slots over here. I don't have any more space, but these are the slots. So your task will be executing in these slots over there. So the task which I have here, this green one and this one, these tasks are actually executing in these slots. Something is running here, something here, 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 here. Parallel execution engine. Now, so and the driver will be communicating at this point. They will be registered with the driver, and the driver will be communicating directly with the containers. So Yarn is not adding any latency right now. And you can say something. Maybe I'll just make the arrow like that and like this. So the driver is directly connecting or talking with these containers. Where the execution is happening for your scenario. Okay, now this is how Spark works. Now, if I take you back to Databricks, and we won't be able to see it like this 1, 2, 3, 4, 5, 6. Not really like that. We can read the execution plans maybe. But what we'll do, we'll simply go back to Databricks where we have the clusters with us, and the cluster is already there. And we even so I think I closed it. So I'll just launch the cluster, the workspace again, and I'll just launch it from here. And if I take you back to the workspace where we have cloned that notebook, you will notice that we can simply click on it, and I did something. Let me move it back over there. Okay. I moved it back because it is depending on the other resources. You see, we have another folder over there. So my laptop is not behaving very well right now. I'm not sure what it is doing. But these are the some notebooks over here, which the other notebook is depending on. So it should be in that folder only. Okay, now what I'll do is I'll just bring you back to this one. And you will see the cluster is not attached. We'll just click on the cluster back again. And we will see if we can execute. I'll just do a run all. There is one step in which it will, we have to go and run back it again. So for now, it's fine. So I'll walk you through what we are doing and how we can work with Spark. And I'll just show you a couple of interesting things over here. Now, you will notice what we are trying to achieve here that is something over here. So what we are trying to understand is that there is a component in Databricks called as Delta Lake. So that's what we are trying to work with. And you see this box, which I'm this ADLS, which I'm trying to create. This is a data lake over here, Azure Data Lake Storage. So ADLS stands for Azure Data Lake Storage. ADLS like this, and there is no upper limit of it. You can keep any amount of data over here. This is a true data lake. So what we're trying to see is we are not much concerned about the Delta Lake architecture today, but I'll give you a brief about it. So, right, but it will be very complicated for us to understand it maybe as part of the fundamentals only. But this is Data Lake. Now, what Data Lake doesn't do is it is not ACID compliant, right? It's not ACID compliant. It doesn't, if anything fails, it doesn't roll back to the previous current state, or it doesn't go to the next state. If there is anything which fails in middle, the file may get corrupted. So the Databricks company themselves, they created and they open sourced one component, which is called as Delta Lake. So you see this blue thing, which I'm trying to do over here. This is what is representing the Delta Lake. So over here, Delta Lake, and this is Data Lake, right? Now, Delta Lake is not another resource which gets created. No, it's only simply a transactional layer or transactional support layer built on top of Data Lake. So what it does is it provides the ACID compliance, and it provides a couple of interesting things. We can run batch jobs. We can run real-time streaming jobs on the data on the same table over there and it will still remain consistent. So what we are doing in that previous example is we have some data which is lying in a Microsoft repository like this, and we are actually mounting it right now. That's one of the steps which will happen over there in this line. Don't worry about that error. That's likely to come because the stream job which we are executing, that stream job actually takes time to run. So I'll just go and click on it before I explain what it is doing. So, okay, run. Okay, now we'll let it run for some time. It's collecting data right now. So let's come back over here. Check this out. Now, you see this step where we are running some setup files over there. So what that step does, basically, this is the Microsoft's repository. Not repository, it's their storage account, which is getting, it's a blob storage account, see .blob.co.windows.net, which is getting mounted to our cluster right now. Not really to the cluster, but let's bring the cluster as well. So this box is representing Databricks, let's say, over here. And in Databricks, we have the cluster there. So this is Databricks, and this is the cluster inside it, which we have created in the previous step over there, which will automatically deprovision once we finish the running the job. Now there is a local you can say there is a concept called as DBFS, Databricks file system. So it's locally available to all the clusters as such. So what that step is doing, it is mounting one Microsoft repository to this DBFS right now over there. So my arrow is going in DBFS right now. So what we do is, I'll just wipe it for this point, but it is going to the DBFS over there. Now, so we have mounted one location from Microsoft and as part of the setup. And then it is having some JSON files over there, around 36, around, it is having a lot of JSON files over there, which will be written somewhere in that. It's annotated over there, but yeah. So yeah, we are having, this is the data which we are working with. It is having index, arrival time, creation time, XYZ coordinate. So it's basically phone accelerometer data, and you can find there's a ground truth. So ground truth is having the activity being performed by the user there. Like, is the user walking? You can say running, walking, sitting up, and you can say standing up or sitting down, or maybe going up the staircase and so on and so forth. So those type of ground activities are being done by the user right now, which we have in the GT as such. The geographic location, the mobile phone's model, and the device type, and information about the user. That's what we have in the data. So this data is there in the repository, and we have around, if I read it correctly, around 36 files and 5,000 records in every file over there in that location which we have just mounted. So what we are doing, we want to read from there, right? And we want to see how can we read in real time and how can we read in a. So when we talk about real time, we are thinking of a stream. Like, can we start a stream and can we read the stream and can we write the stream, or can we do it in a batch mode, not stream, right? You run it on some schedule. So we are doing the stream first. So we are starting the stream. So for the stream to be started, we should know the schema of the data. So that's what we are defining here. That what is the schema of the data? We have arrival time is one column, creation time, device, index, model, user, geolocation. Now, geolocation is nested. It is having city and column in country inside it. We have ground truth, IDs, XYZ coordinates, and so on and so forth. Now, okay, so over here, we basically, this is, if you can notice this part, we are creating one data frame called as raw events data frame. And this data frame is what it is doing. It is reading read stream, format JSON. JSON is the format of our file. Schema we just defined in the previous cell. And how many files in one trigger? One. You can play with this value. If you put two, then it will, in one trigger, it will try to read two. If your cluster doesn't have the resources, and if you try to read a lot of things, it will not have any impact after one point. And from where, this is the location in the mounted storage account. This is the folder location over there. From there, it has to start reading the file. So if I take you back, so at this point, what has started is there is a data frame. And what's a data frame? Data frame is something which I can make maybe like this. So if these are two workers over there, so imagine this data is being distributed over here in these two workers over there, and that's a data frame, the red part. So what we are doing is we are creating one data frame right now, which I'll just make it over here, raw events data frame, this blue one, and the data is, and we are trying to read the data from the source location over there in that one line. Now, after that, what we do is we have started the read. We would like to persist it. We would like to save it. So to save it, we are writing it over here in this line. That's just annotation. So we are writing it over here. So we are saying that raw events data frame, why don't you go and you get written in this path, which we have defined earlier called as bronze path. So let me scroll up and show you. I think I skipped that, where we defined the path. So you see over here. So in the mounted location, we have this is not the mounted location. Right now, this is in the DBFS only. But this, once we have mounted our own data lake, it will be inside data lake. So I'll explain this as if we have already mounted a data lake, which we actually over here, we are not doing it. But you can see we have activity, we have bronze, silver, gold, three paths are there. Three folders are there. And in bronze, there is a checkpoint. In silver, there is a checkpoint. Gold, there is a checkpoint. There is another folder in gold called as group count, and then a checkpoint inside it over there. So we are writing in the bronze. So what happens? Bronze is representing the raw data which we are getting from the source, and we are writing it over there. the bronze path in this line over here. Format delta is basically Parquet file format. So data is going in our hypothetically mounted ADLS over there. So like this. So imagine this is the bronze table. So this is the bronze table over there, and the raw data is going in this one. So like this, and then this is actually in a path over there, which is called as a bronze path. And inside the bronze path here, Parquet files will be there. That's where that is persisting. And inside this bronze path, there is also a checkpoint folder over there where the checkpoints are being created. Checkpoints are the ones with which checkpointing is done. Like basically, if you read till 55 rows, then now you have to read from 56. All that information is in the check. Now, so now what we will do, you will notice what we are doing is we will create another data frame over here. Imagine one more, and then whatever data we have here and whatever data we have here, we will enrich the data. And with the new data frame which we'll create, we will call that particular, you can say as delta silver table, and then we will persist that also. So that the silver one, which is the one which is having cleaner data, it is clean, it is enriched right now. It's not clean, it's just enriched. We will add few values from the reference. So this is, we are calling this a lookup data frame, and we'll read it the bronze raw, and this is the one where we have the raw data in the bronze. So with a lookup data frame, we will enrich the data, and that output is what we are saving as the silver file. This is silver over here, and it goes in this location like this, and there is a silver checkpoint also like that. So that will be the next step. So if I take you back, and if I can show you that part. Okay, so this is where we have that lookup, and this lookup is having country codes basically. So we are reading from as a Parquet file from the Microsoft's mounted data store, and then select the English short name of the like countries and the country codes as well from that lookup frame. Now after that, we are doing what we just discussed. Now if you can see, okay, let me run this. Earlier we didn't have the data, so the last time it didn't run because that when you start the stream, we executed it immediately. So there was no data, so it was saying that I don't have any data. What do you want me to join? So what we are doing is we are doing a join over operation over here, the left join operation on the two data frames, which I have just created in my diagram as that arrow. Like that's where the join is happening over there. Imagine here like this. And the output of that is basically this parsed event data frame, which we are going to save over here. So we'll run this. So what is happening is the parsed event data frame is going as a Parquet file format in the location in append mode. Append mode is append only. You understand append, right? Append operation. And then the where to write in the silver path over there. Now we can also check all these things. List down the files and so on and so forth, but just want to show you the main things first. Now, then what we are doing is, if you can check this out over here, so the same format, spark.read stream, read from the silver path over there, do a group by on top of it, do a count on top of it, do a tumbling, this is basically tumbling window over here. Tumbling window is a type of windowing job which we run, which doesn't overlap because the data is coming nonstop in a stream. So it doesn't overlap. Now, then what we are doing, we are in the same operation. Now, if you see, we are doing the write as well. So we have read it first over here. You see this till here, and then we are writing it over there. Write stream. Where in the grouped count. What is this grouped count? Grouped count is the gold path. Gold path is the one where we have the aggregated data. So if I take you back, so we have done some aggregations now on the silver like this, and we have created another table called as gold table, called as grouped count table like that. And that grouped count is a type of gold table. Gold table is the one which is having aggregated data right now. So in the gold path, there is another folder called as a grouped count, and this is basically there inside the in the hypothetically mounted data lake. We haven't mounted this right now. It is happening in DBFS. All of this is going in Databricks file system. Okay, so this job will keep on running over there. I don't have to worry about that. But I can just show you that we can also run queries on top of it, like SQL queries. See, so this is a goal table. So we can run the SQL query on top of it. Select star from the group count, and any data, anyone who's comfortable more in let's say Spark SQL will be able to, or SQL itself will be able to very easily pick up the SQL part. And that's the output which we have, the aggregated accounts. So someone is stare down bike, riding a bike, sitting, no value, and so on and so forth. Okay, I'll skip the plot part over there. We have around 5 minutes with us. So I just want to show you a couple of interesting things now. So this is where we are doing we are reading this we are reading the same data, but in batch mode right now. So you will see that the syntax is different. Spark.read format JSON schema we already defined some time back, and then the load from that path and write in the delta format in the bronze path. So what this is doing is, and range 4. Basically, there are 4 folders, batch 1, 2, 3, 4. So we are recursively reading from all the 4, 5 folders over there in batch mode. So this is how simply you can read from these sources, and you can write it then. So let's say once we have we read it, uh, then let's write it down. So okay, that part I think I it's not there. I have skipped it, but you can simply write it spark.write as well, and we're in the write in the output location, which basically is over here. If I can highlight it for you, like this dot write. So we read it and then we write it in the bronze path. So what is going on in this line is that the stream was going on. We haven't stopped the stream. Stream is happening parallelly, but we also have started another batch job, and we are reading recursively in batch mode, and we are persisting in the same file over there. So that's the beauty of Delta Lake, that nothing goes corrupt, and it will still be consistent. If something goes wrong, it will roll back to the previous healthy state, and that's the other part of your asset compliance. So this is what we have done today, and I'll give you this link of this workbook, of this notebook, if you guys want to try this out. I'll just go to my secondary page. I'll copy the link for you. And I can I'll put that in the chat window. So this is the one which I have used, that one. You can use it. Okay, so let's quickly summarize what we have done. We basically have worked with so we basically have understood the basics of the Spark, like how Spark architecture work. We also have understood that Databricks is not one-to-one mapping with yarn-based Spark. It is similar to it. It also uses Spark, but they have done their own. Databricks is another company in itself, so they have done their own optimizations on top of it over there. So there are a few minor changes, minor or major changes as such. That's the big data ecosystem, where we have the green box represent Hadoop, and the jobs will be broken into stage and into task. One partition will be processed by one task. And something important over here, that we have to calculate the number of slots. The slot represent how many tasks can execute. So in one slot, one task will execute. So 16 slot means 16 tasks can run in 16 slots. And that's a basic about Databricks, that what is credential pass-through, 3 type of clusters that we have. And that we can do operations like read, write, and transform, and so on and so forth with Databricks. So if I take you back to the reading links over there, so after the session, you can simply click on the link over here on this one, and you can go in. You can even log in and you can save your progress as well. Go through it, understand the details of the job. So whatever we have discussed is also here in a way more you can say step-by-step manner. Like what the executor is a Java virtual machine running on a node, typically one instance per node like this. So you can further go and read about this. So let me know about your questions, and then we'll wind up this session after that. Okay, so I'll just scroll up in the chat. Let me. Who will create those notebooks? We will create those notebooks. Developers will make the notebooks. And yes, everything is recorded. It goes on YouTube. And Rashmita has already shared the links with us. Delta architecture, we just discussed it. Delta architecture is built on top of Data Lake, and it will provide the ACID compliance. Does GCP Spark operator on Evro works the same way compared to Spark Yarn? The Spark operator, the is that Kubernetes based? I'm not sure if it works exactly same as Spark Yarn based on Yarn. Now, in which case we should go for Azure Databricks versus Data Factory? Data Factory is not comparable with Databricks. Data Factory is basically, you can say, a tool by which we can do ETL, ELT. We can orchestrate. Now, in Data Factory, you will use Databricks as one of the step where you will do the transformation. So whatever we have done today, we can automate it, we can schedule it, and that scheduling will be done with the help of Data Factory. There is a concept in Data Factory called as data flow that we can even compare with Databricks, because data flow is basically a UI-based Spark solution. It's an UI-based Spark transformational activity that we can compare with Databricks. But that activity is UI-based, so it is not having all the flexibilities of Databricks. So Databricks is a compute cluster. Data Factory is like it's oozy. It's similar to Airflow. Now, OpenShift is basically your it's Kubernetes only. So yeah, the Databricks. So it's not Yarn. It's the cluster manager is Kubernetes. So if you are running it on Kubernetes, then there is a Spark operator running inside in a pod over there, and this is not comparable with that. The only thing which is comparable with the Kubernetes-based cluster manager is the executor. Like here we have the executor in Java virtual machine. There we have the executors in the pods. So that part we can compare. I have done a session of last month, I think, on Spark, which is Kubernetes based. You can check this out in the YouTube recordings and go through it. What is the difference between Event Hub and Databricks Stream? Both are good. The Event Hub is a Kafka-based cluster ingestion solution. The Databricks Stream is a different thing. Event Hub is a Kafka. You can use both of them together. Like Event Hub can stream inside Databricks. In Yarn, do you create an operator? No, no. This is different. This is the original one. Kubernetes base is the new one. Databricks and HD Insight. HD Insight is having 7 type of options there. Like HD Insight is having Spark, Hadoop. We can have Storm. We can have Kafka. We can have interactive query clusters. We can have machine learning cluster there. So HD Insight is an umbrella of services. And if we compare the HD Insight Spark with Databricks Spark, then HD Insight Spark is basically more infrastructure as service oriented. You have more control there. Databricks is fully managed or nearly fully managed. And I generally prefer Databricks over HD Insight. We have use cases where Spark works with Event Hub. Is Event Hub a good choice? Event Hub is a very nice choice. Event Hub is basically built based on Apache Kafka. Apache Kafka is an PubSub is the PubSub model over there, or you can create the PubSub solutions with Apache Kafka. And Event Hub is a managed solution which is built on top of Apache Kafka. So if in case you don't have more requirement than 100 partition, you can go for Event Hub. 100 partition is a big number, and it's a fully managed solution. So you don't have to work with Kafka. You don't have to keep it high available. You don't have to work with the VMs, and everything is a managed solution, SaaS solution. So Event Hub is a very good choice. Right? Okay. So then I guess you can have any, if you have any further question, you can find me on LinkedIn. You can even, you can ping me over there. If you have any questions, let me know. And you'll find me the next session as well. Please join the Reactor group on YouTube so you get all the recordings. And and join the channel, subscribe to the channel, and we have join us on the meetup page and join us in the LinkedIn group as well. So you can stay in touch with the upcoming session, right? Thank you. Thanks, everyone.
Thank you, Shivam, for the session, and thank you all for joining us today. Please do share your feedback about today's session. Also, please feel free to use the Learn module link shared in the chat section. Also, right now I'm displaying so you can see on the screen as well. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.
Thank you. Thanks, everyone. Thank you, Rashmita.